Assalamualaikum and a very good afternoon. Okay, today we will present solid and liquid separation. My group member is me, Muhammad Syazwan, Fatin Najibah, Hafizah and Noran. Okay, the theory and the fundamental of solid liquid separation. Okay, solid liquid separation involves the separation of two phase, which is solid and liquid, and it is used in many process. Okay, for the example is to recover the valuable solid component. Because we want to separate liquid and solid, so the first example is to recover the solid, or we want to recover the liquid, or we want to recover both solid or liquid, and also we want to recover neither the phase. Okay, and many biological and organic substance occur in a mixture of different components in solid. In order to separate the desired solid constituent, remove an undesirable solid component from the solid phase. The solid is contact with liquid phase. Okay, and because we want to separate both the solid and liquid, we need to make we need to make a contact between the solid and the liquid. Okay, the two phases are in intimate contact, and the solid or solids can diffuse from solid to liquid phase, resulting in the separation of the component. Okay, we can say the original is from the solid, so we make contact with the liquid to diffuse it from the solid to liquid, and it is also called simple leaching. Okay, the mechanism of leaching extraction involves two steps, which is contacting step. Okay, the contacting step is the step which the solvent and the material to be treated so as to transfer soluble constituent to the solvent. And the separation step. The separation step is the solution form from the relatively exhaust solid. Okay, these two steps may conduct in separate. So the contacting step and the separation step, there are two ways whether it is conduct in a separate ways or in the same equipment. Solution resulting from separation step is termed overflow, and solid left over are termed underflow. Okay, this flow we will see the next slide. And here. Okay, for this, as we can say, the overflow is at the top and the underflow is at the bottom. And this is the diagram that is we need to draw this to answer the question. Okay, and this is the formula that we need to know. Yeah, you guys can write it on your note. Okay, we need to remember this. Okay, this is the example that we come up in a you guys can read. Okay. In a single stage leaching of soybean oil from flake soybeans with hexane, 100 kg of soybean containing 22% oil is leached with 80 kg of hexane solvent containing 3 soybean oil. Okay, from here. Okay. 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 As we have read from the question, we get the 80 kg. The 80 kg is the value for the V2. Here, because the V2 is here, it is the input. We get the 80 kg here. Okay. Okay, and this 3%. is here, XA2, and the XC2 is we just divide and we just subtract 1, we subtract with the 0.03 because 3 is the 3%, so we divide by 100, we get the 0.03, and we can minus 1 minus 0.03 to get the value for the XC2, 0.97. Okay, and we continue. The value of M for the slurry underflow is essentially constant at 1.5 kg. So it is stated already that the value for the N is 1.5. Okay, here the value for the N is 1.5. Okay, so calculate the amount and composition of the overflow V1 and the underflow slurry L1 given the stage. So we want the V1 here and the L1 here. Both is the output. Okay, from the formula that I shown you all just now, we can calculate the L0. L0 we get 22 kg, and we want to find the N. So from the formula we have L0 plus V2. V2 is given and L0 we just calculate, so we get the 102 kg. Okay, and this is also the formula. From this formula we want to find the XAM. So we just put the value for each of the variable, and we get the XAM is 0.2, and we continue by search for this NM. Okay, both XAM and the NM we will use it for the graph later. I will show you. Okay, and we will continue. We have already calculated the NM, so here we can calculate the L1 because the question wants us to find the L1, and here L1 we get the 51 kg, and then we can continue. This is from the formula, and we have already know the M value, so we can put and we can get the V1 is 51 kg. Okay, and so here is also SA1. Okay, from the previous calculation we calculate the XAM and the NM. Okay, both this value is we can find the value for the M, the corresponding of both value on the graph. Okay, and this is example of the industry, current industry practice / dewatering. Okay, this use the concept of solid liquid separation. Okay, this is the unit operation involved in the dewatering: bed press, centrifuge, screw press, plate and frame press, and vacuum filter. Okay, the / dewatering process is relatively simple, as it is increasing the dry solid content of the slush with different type of equipment. Okay, and this process always require the use of at least some flocculant aid that keep the excess sludge flocculate in the dewatering unit. Okay, we need this to keep the excess flocculate in the dewatering. The flocculate is flock. It's like sometimes coagulation chemicals such as iron or aluminium salt are also added in order to enhance the efficiency of flocculate aids. Okay, and we put the flocculants, but to enhance the flocculants, we sometimes put chemicals such as iron or aluminium salt. Okay. And some research projects are developing dewatering method without any chemical. Okay, there are some research done, but the separation effect and the reliability are not yet sufficient. So from now, we still mostly use with chemical, because without chemical we still cannot get the sufficient amount. Okay. After dewatering, the dry solid content of the sludge is usually between 19% and 30%. Okay. Depending on the dewaterability, it is possible to reach a dry solid content of up to 50%. Okay. One of the examples that we can do to achieve the 50% is we can use the chamber filter process, which can get the higher dry solid contents. Okay, the maximum dry solid contents can be determined in a laboratory, and after reaching the maximum dry solid content, the dewatering, the water left in the sludge is bound in the cell and can only be reduced with sludge drying. Centrifuge and valve filter press are currently the most popular dewatering method in municipal wastewater. It is we normally use it for the city, in the city, and in the city. And due to their good operation and cost efficiency, it is suitable. And chamber filter press are expensive compared to other press and are therefore used more in large application as well. And because the centrifuge and valve filter is more affordable, so we often use it for the city usage, and for the industry usage we use the chamber filter because it is expensive but it is more efficient. Hydraulic press originally developed for the food industry with high hygienic demand and also expensive. Okay, for the food industry, because we talk about food, we need to make the food uncontaminated. So we need to make sure that the process that we use is hygiene. So we use the hydraulic press. And the screw press are more suitable and used for sludge containing fiber material from the pulp and paper industry. Today there are also some screw press applications in the Baltic Sea region, especially in small and medium-sized city treatment plants. Okay, and so it is depend on the material that we use and the type of separation, like we use for the industry or in the city or for food. So we need to choose wisely which press that we want to use. Okay, the effect of the current industrial practice. Okay, the effect of the industrial practice, the effect for human health is mono-incineration and co-incineration damage human health. Then the other scenarios, effect of mono-incineration will caused primarily by the emission of particulate and nitrogen oxide combined with the influence of antimony and arsenic ions. Ecosystem quality, the carbonization scenario had a beneficial effect in ecosystem quality because of substitution of biocoal for some coal in the co-firing process. And climate change, it also affects climate change. Landfill scenario had the greatest effect because of the greenhouse gas emitted during the landfill process. And the resource, mono-incineration had greatest negative effect on resource because of its high energy use, and carbonization and co-incineration had positive effect because of coal substitution and bioelectricity generation. And to minimize the negative towards society health and safety, so we don't want to make it too bad, we need to apply the correct polymer and dosage to improve in both treatment performance as well as economy. So we just don't want to get the optimum product, but we also need to make sure that the process is not harmful. So we need to apply a correct amount, and by increasing the use of polymer dosage and controlling the counter-operating parameters, the discharge solid become progressively drier. Okay, so as I said said earlier, we not only want the product to get the optimum value, but we also want to minimize the negatives towards society. That's all from us.